Welcome. In this video, I will talk about maxima and minima of function of two variables. In case if you are new to the channel, you should subscribe it because here you will get good quality video content. My videos are usually longer videos, but we solve multiple kind of problems, so it gives you a very clear concept related to any of the topic. So let's start. First of all, understand that what I mean by maxima and minima of function of two variables. So to understand this, let us first look at the things that I have written here, and I will explain it also. So you need to look at this very carefully. So let there is a function f of x comma y, and this function is defined and continuous in some closed and bounded region R. So suppose we are taking a region, suppose I call this region, and this region is R. Okay, and there is a point in this region which I am calling as a comma b. This is a point a comma b. This point is an interior point of R, means this is not lying on the boundary, this is inside the region. And a plus h plus b comma b plus k be a point in its neighborhood. So by neighborhood, what I mean that I take any points around this point a comma b. It may be in any direction, right? And the coordinate of that point I am calling as a plus h comma b plus k. Okay, so if a comma b is a point, then a plus h comma b plus k is a point in its neighborhood around this point a comma b. Now there are two possibilities. We call the point a comma b as a point of relative or local minimum, right? We are using this term relative minimum or local minimum if the function value at the point a plus h comma b plus k is greater than or equal to the function value at a comma b for all values of h and k in its neighborhood. It means what? That you calculated the function value at a comma b, but the moment you move in any direction around the point a comma b, the function value at those points are greater than the function value at a comma b. It means what? It means that this point a comma b is a point of relative minimum. Similarly, there may be another possibility that I calculate the function value at a plus h and b plus k, and if the function value at a plus h comma b plus k is less than or equal to the function value at a comma b for all possible values of h and k, then this point a comma b is said to be the point of relative maximum or local maximum. It means what? That the function value at a comma b is maximum in its neighborhood, right? So at a comma b it is maximum, and if you move in any of the direction around a comma b, the function value will decrease. Okay, a function f of x comma y may attain its minimum or maximum values on the boundary of the region also, because when I was talking about this, I was talking about the point being the interior point, but it may attain its maximum or minimum value over the boundary of the region also. So the smallest and the largest value attained by a function over the entire region including the boundary are called absolute minimum or absolute maximum respectively, right? So there are two concepts. One is a relative minimum, a relative maximum. By relative minimum I mean that you are taking any point and that point function value at that point is minimum in its neighborhood, means if you move around this point the function value will increase. Then that point is point of relative minimum. Similarly, there is a point of relative maximum, means that if you move around that point the function value will decrease. The function at a comma b is maximum, but when I am talking about it, I am talking about it a small neighborhood. But there is a possibility that there may be a point and at this point the function is maximum in entire region R, then this point will be called as absolute maximum point, right? So in this video I will be focused more on finding the local maxima and local minima. But in case if you feel like you want to also learn about absolute maximum or minimum, then you should let me know through the comment section. I will create a separate video for that. Okay, so let's start. So first of all, what is the working rule to find the local maximum or local minimum? This is the most important slide in this video, so be careful about this. So the process is very algorithmic. What we do, first we find del f by del x, and then we find del f by del y, and we equate both of them to 0. So we write del f by del x is equal to 0, and we write del f by del y is equal to 0, and then we solve them together. So when we solve them together, we get some points. Those points that we get are known as critical point or stationary point, right? In the next step, we calculate r, that is del 2f by del x, x square, s del 2f by del x del y, and t, that is del 2f by del y square. Some people can also write as r as f of xx, s as f of xy, and t as f of yy. These are the standard notation, r, s, and t. Now what we do, we calculate the value of rt minus s square at the critical point that we have got in the step number 1, and we check that whether rt minus s square is greater than 0, less than 0, or equal to 0. So there are 4 different possibilities. The first possibility is that if rt minus s square is greater than 0 and r is also greater than 0, then it is said to be a point of relative minimum. Second possibility is that if rt minus s square is greater than 0 but r is less than 0, then it is a point of relative maximum. Third possibility is rt minus s square is less than 0, then the function has no minimum or maximum at this point, and in this case this point is called a saddle point. I will also show you through the figure that what is this minimum point, maximum point, or saddle point. The fourth possibility is, there are 2 if here, so remove it. If rt minus s square is equal to 0, then we cannot draw any conclusion that what is the nature of the point at which rt minus s square is equal to 0. And to decide the nature of the point at the point where rt minus s square is becoming 0, we require to delve into the further detail, means we need to further investigate to decide that what is the nature of it. Means you can think like that the local police station will fail to solve the case, so it should be handed over to CBI. Okay. Now if you look at the pictures that I have taken here to understand the local minima, local maximum, and saddle point, this is the graph generated for the function x square plus y square, and you can see that this point on the surface, let me use a different color so that you are clear about this point, if you move anywhere around this point, the function is increasing, right? So this is a point of a local minimum, right? In this case, if you take this point here and if you move anywhere around this in any direction, the function will decrease, means this is a point of local maximum. But if you look at this point here, I don't know whether you can see, if you look at this point, then you notice 2 things, that if you move in this direction or in that direction, in this direction, the function is actually decreasing, right? And if you move in this direction, the function value is increasing. So this, at this point, the function is neither increasing nor decreasing, right? So because you can say that in this direction if I am moving, it is decreasing, in this direction if I am moving, it is increasing. So this kind of points are known as saddle points. Okay, so now let us start the problem solving, and I'll be taking multiple problems, so be focused, and I would suggest you to take a pen and paper and do the problem solving together with me. So I'll be doing it step by step. So solution. So we have to test this function for relative maximum and minimum. So what is the step number 1? Step number 1 is that first find del f by del x, right? So del f by del x, I will prefer using the term f of x because it is easier, but you should be careful that these are both the same thing. So if I differentiate this partially with respect to x, xy will give me y, and 9 by x will give me minus 9 by x square, right? And what we have to do, we have to first let me find f of y. So f of y will be what? F of y will be, if I differentiate this with respect to y, I will get x, and 9 by x will be 0, and this 3 by y will give me minus 3 by y square. So to find the critical point, what we do, we put f of x is equal to 0. This implies y minus 9 by x square is equal to 0, and also put f of y is equal to 0. So this will implies that x minus 3 by y square is equal to 0. Let me call this equation number 1, and let me call this equation number 2. Now these two equations I have to solve together. So what we can do, to solve it, we can find the value of one of the variable. So let me how to proceed. Let me, there are two different ways, but let me do like this. So what I do, I write from 1 I get y is equal to 9 by x square, right? And from 2 I get x is equal to 3 by y square. So I want to substitute the value of y here in this. So I will get what? I will get 3 by, and y is 9 by x square, so it is 9 by x square whole square. So what I will get? I will get 3 by 81, and it will be x to the power 4, so I can take x to the power 4 in the numerator. So 3x to the power 4. So this gives me what? This gives me 3x to the power 4 is equal to 81x, right? So simplifying further, I am continuing in this direction. So I can write 3x to the power 4 minus 81x is equal to 0. This will give me what? This will, I can take 3x common. So I will get x cube minus how much? 27 is equal to 0. Now this will give me 2 points, that is x is equal to 0 and x is equal to 3. Now ladies and gentlemen, some of the students who are smart, or intelligent, they might have one objection here. The objection is that they will say that, sir, here we have an equation whose degree is 4. So how many roots we should get? We should get 4 roots, right? And when I am writing the solution for x cube minus 27, I am just writing x is equal to 3, which is not correct. That is what you may argue, and I will tell you that yes, you are correct. But the point, I have not written the other 2 roots, because the other 2 roots for x cube minus 27 will be imaginary roots. Let me explain it here. Because if I take x cube minus 27 is equal to 0, and if I simplify it, it can be written as x minus 3. A cube minus b cube is a minus b, and then x square plus ab, so that is 3x plus b square, that is 9, that is equal to 0. I hope you remember the formula, a cube minus b cube, that is a minus b, a square plus ab plus b square. So this will give me x is equal to 3, right? And what will be the roots of this? If you look at the quadratic equation, 3x x square plus 3x plus 9 is equal to 0. For this, the discriminant d is b square minus 4ac, that is 9 minus 36, which is less than 0. So that will give me imaginary roots. So because we are talking about real xy plane, we will not talk about the imaginary roots. I hope you don't you are not getting confused. So that is why I have just taken the 2 points, x is equal to 0 and x is equal to 3. Now if I have got x is equal to 0, to get y, I have this equation, that is y is equal to 9 by x square. So if I take x is equal to 0, y will tend to infinity. So means x is equal to 0, actually we can't take, because if I take x is equal to 0, the function itself will not be defined, Are you getting my point or not? Because here we have 9 by x, so I can't take x is equal to 0 or y is equal to 0. So I have to ignore this x is equal to 0 also, right? Because I hope you got the reason, because if you take x is equal to 0, y will approach to infinity, which is not acceptable because we are talking about points in xy plane. And another reason you can give that for x is equal to 0, the function itself is not defined because x is equal to 0 can't be taken in the denominator. So the next thing I can take is x is equal to 3. So if I take x is equal to 3, y is equal to 9 by x square. So 9 by 3 square is equal to 1. So we have got the critical point 3 comma 1. We have just got one point, that is 3 comma 1. So this is first part of the problem, that we have got the critical point, that is 3 comma 1, right? So step 1 is over. I just want to show you this, that we calculated del f by del x and del f by del y, equated them to 0, and then we solved them to get the critical point, that is 3 comma 1. Now the next step we have to perform in the next page. So I'm moving to the next page. So the next thing is we have to calculate r. So what is r? R is f of xx, means partial derivative del by del x of del f by del x, right? So what is del f by del x? Look at this here. Del f by del x is y minus 9 by x square. So if you differentiate it again, let me write so that you don't get confused. It is del by del x y minus 9 by x square. So you will get derivative of y with respect to x will be 0, and 9 it will give you a minus 9 and minus 2 by x cube. So it will be like 18 by x cube, right? Similarly, if you calculate s, that is del by del x of del f by del y. I hope you remember this. Let me show you again. This is what this I have to calculate, del 2f by del x del y. So that is del by del x of del f by del y. So del by del x of del f by del y. So what is del by del x? Del by del x. And what is del f by del y? Del f by del y is x minus 3 by y square. So I take x minus 3 by y square. So if you calculate this, you will get 1, because del x by del x of x will be 1 and this will give you 0. And then we have to calculate t, that is del by del y of del f by del y. So del by del y of, and what is del f by del y? In the previous page I have calculated. So that is x minus 3 by y square. So I write x minus 3 by y square. So this will give me minus 3 minus 2 by y cube. So I will get 6 by y cube. So we have got r, s and t. So the next thing is I have to calculate rt minus s square. So it is 18 by x cube into 6 by y cube minus s square, that is 1. So we got 108 by x cube into y cube minus 1. Now we have just one critical point, and the critical point that I have got is 3 comma 1. So let us take the point at 3 comma 1. So what we have to do? We have to calculate the value of rt minus s square. So rt minus s square will be 108. X is 3, so I will write 3 cube. Y is 1, so 1 cube and minus 1. So I will get 108 by 27. Yes or no? So 108 by 27 is 4 and minus 1, that is equal to 3, means it is greater than 0. So we have got rt minus s square is greater than 0. The first two possibility may happen. So now to decide further, we have to evaluate r. So what is r here? R here at is 18 by x cube, right? So r is 18 by x cube. So at the point 3 comma 1, x I have to take 3, so I will get 18 by 3 cube. So that is basically how much? 18 by 27, which is a positive quantity greater than 0. So at point 3 comma 1, rt minus s square is greater than 0 and r is also greater than 0, means 3 comma 1 is a point of relative what? Relative minimum. I hope you are clear about this. So this is the end of the first problem. We are around 20 minutes in the video. So now quickly solve more problems, right? I am not looking at the time, whatever time it will take, but I am going to complete a lot of problem solving. This is another interesting problem. Test the function for a relative maximum and minimum. So in this problem I will not spend much time because you are clear about the basics. So first I calculate f of x, which is x cube will give you 3x square, y cube will give you 0, minus 3x will give you minus 3, right? And I have to put that equal to 0. So from this I get 3 into x square minus 1 is equal to 0. So this will give me x is equal to plus minus 1. If I calculate f of y, I will get what? I will get 3y square minus 12 is equal to 0. So from this I can take 3 common. I will get y square minus 4 is equal to 0. And from this I will get y is equal to plus minus 2, means 2 and minus 2. So what are the critical points I have got? I have got 4 critical points. So the critical points are the critical points are 1 and 2 and minus 1 and 2 and minus 1 and minus 2, right? I took 1 and minus 1 with 2 and minus 1, and what is the other point that I will get? 1 and minus 2. I hope you understood this, because I could have written it like x is equal to 1, y is equal to 2. So I got the first point. X is equal to minus 1, y is equal to 2, second point. X is equal to minus 1, y is equal to minus 2, and x is equal to 1 and y is equal to minus 2. So there are 4 critical points we have got. Now we have to decide the nature of these 4 critical points. So for that, what we have to do, we have to find r, that is f of xx. So I have to differentiate this 3x square again. So I will get 6x, right? I have to find s. I am going to write like this so that we can save space. S is f of xy. So means I have to differentiate fy with respect to x. So if I differentiate this fy with respect to x, there is no x term, so it will become 0. And then I have t, that is f of yy. So if I differentiate this with respect to y, I will get 6y, right? So just to save space, I am using this part. So next thing is I have to calculate rt minus s square. So rt minus s square is 6x into 6y minus 0 square. So that is equal to 36xy. Now we have 4 points. So let us quickly look at the value at all these 4 points. So I take the first point, that is at 1 comma 2. So at 1 comma 2, rt minus s square is equal to 36 into 1 into 2, that is equal to 72, and it is greater than 0. So if rt minus s square is greater than 0, then we have to evaluate the function value of r also. So what is r? R here is 6x, right? So at 1 comma 2, r value will be 6 into 1, that is 6. So it is also greater than 0. So it means what? That 1 comma 2 is a point of relative minimum, right? I hope you remember this, that if rt minus s square is greater than 0 and r is also greater than 0, then it is a point of relative minimum. Then we take the point, let me use this space here because I don't want to move to the next page. So I calculate at 1 comma 2 we did. Then let us take the point minus 1 comma 2. So at point minus 1 comma 2, rt minus s square is equal to 36 into minus 1 into 2, which is equal to minus 72, less than 0. And when it is less than 0, we don't have to do anything, means this point minus 1 comma 2 is a saddle point. This is a saddle point. Now I calculate the function value at minus 1 comma minus 2. So at function value means this rt minus s square. So at minus 1 comma minus 2, what is rt minus s square? So you are smart enough to see that it is 36 into minus 1 into minus 2, so that is equal to 72, again greater than 0. So if it is greater than 0, then we have to evaluate the r also. So what is r? R is 6 into minus 1. 6 into minus 1, that is minus 6, but it is less than 0. So if rt minus s square is greater than 0 but r is less than 0, it is a point of relative maximum. Right, so this point was point of relative minimum, this point is point of relative maximum, and minus 1 comma 2 is a saddle point. Now there is one more point, that is 1 comma minus 2. So I am going to squeeze the things here. So at 1 comma minus 2, at 1 comma minus 2, what is rt minus s square? You are smart enough to see that 36 into 1 minus and into minus 2, that is equal to minus 72, less than 0. So this is also a saddle point. So here in this problem we have got two saddle points, one point of relative maximum and one point of relative minimum. Right, create your own notes and write it carefully. So two problem done and dusted. Actually I thought of using this page, but I managed in one page only. This will be a slightly more engaging problem. So let us look at this, and I am going to solve it smoothly, and I would suggest you that please do it together with me. So what is the steps? A step is first find f of x. So if I find f of x, 2x square will give me 4x, 2y square and all will give me 0, and now I will write directly, that is 4x cube is equal to 0. So this, if I simplify, I can take 4x common and I will get 1 minus x square is equal to 0. And we have just x here, so we can solve it. X is equal to 0, 1 and minus 1. Then evaluate f of y. So if you differentiate this with respect to y, you will get minus 4y, and from this you will get plus 4y cube is equal to 0. So from this you can take minus 4y common, you will get 1 minus y square. So ladies and gentlemen, for this also you will get y is equal to 0, 1 and minus 1. So what are the critical points? So the critical points that you are getting, can you guess how many critical points we have got in this case? We have got actually the 9 critical points, because if I fix x0 and y0, the first point, then I can fix x0, y1, I can fix x0, y minus 1. I can fix x1, y0, I can fix x1, y1 and x1 and y minus 1. And then I can fix x minus 1, y0, x minus 1, y1 and x minus 1 and y minus 1. So there are 9 critical points that we have got in total. So the next thing is that we have to calculate rt minus s square at all these 4 points. So for that, first we calculate r, that is f of xx. So f of x is this. So if I differentiate it with respect to x again, I will get 4 minus 12x square. For our convenience, I can take 4 common and write it as 1 minus 3x square. Then we have to calculate s, that is f of xy. So I have to differentiate fy with respect to x. So fy is this, and if I differentiate it with respect to x, I will get 0. Then I have to evaluate t, that is f of yy. So if I differentiate this with respect to y, I will get minus 4 plus 12y square. So from here I can take minus 4 common and I will get 1 minus 3y square. So we have got r, s and t. Okay. Now what is rt minus s square? So if I write the expression for rt minus s square, it will be 4 into minus 4, that is minus 16 into 1 minus 3x square and 1 minus 3y square, and minus s square, that is minus 0 square, so I am not writing that. Okay. So the first part is to get the critical point, second part is to calculate rt minus s square is done. Now I have to check the nature of all these points. So for that I am moving to the next page. Okay. So for your convenience, I already have written all these things. So we have rt minus s square that we got here. minus 16 into 1 minus 3x square into 1 minus 3y square. R is 4 into 1 minus 3x square that I have written, and all these 9 points are there. So let us start one by one. So first we are taking the point 0, comma 0. So at 0, comma 0, if I calculate RT minus S square, I will get minus 16. And if I put x is equal to 0, I will get 1 minus 0, y is equal to 0, 1 minus 0. So I got minus 16, which is less than 0, so no need to do anything, because once we get RT minus S square less than 0, this point 0, comma 0 becomes a saddle point. Okay, so the first point is over. So I talked about 0, comma 0. Now take the point 0, comma 1. So if I take the point 0, comma 1, RT minus S square will be equal to what? Minus 16 and 1 minus 0 and then 1 minus 3. So I will get minus 16 into minus 2, that is equal to 32 greater than 0. So at 0, comma 1 we are getting RT minus S square that is greater than 0. So we also have to look at the value of R. So R will be what? R will be 4 into 1 minus 3x square. So x is 0. So if I write x square, I will get 3 into 0 square 0. So that I will get 4. So this is also greater than 0. So 0, comma 1 is a point of relative minimum, because RT minus S square is greater than 0 and R is also greater than 0. But I want you to note a very important thing here, that if you look at the RT minus S square expression, it contains x square term and it contains y square term. So if I take x is equal to 1 or minus 1, the function will not change, the value will not change. And R also has x square term. So if I take x 1 or minus 1, it will not make any difference. So the point I am trying to highlight is that for 0, comma 1 and for 0, comma minus 1 also, the expression will remain same. You can verify it, that if you take 0, comma minus 1, what will be RT minus S square? Minus 16, 1 in place of x you put 0, and y square will remain this minus 1 square, so it will remain 1 minus 3. So it will remain 32 only. And for 0, comma minus 1, again R value will be 4 into 1 minus 0, that is the same thing. So 0, comma 1 also is a point of relative minimum, means both the point like 0, comma 1 with a positive sign and with a negative sign are points of relative minimum, right? So we have already talked about these 2 points. Now if you talk about a point at 1, comma 0, so at 1, comma 0, what will be RT minus S square? So RT minus S square here is minus 16, 1 minus 3, because I take x is equal to 1 and y is equal to 0, so 1 minus 0. So again I got 32, that is greater than 0. So we have to calculate the R value, that is 4 into 1 minus 3x square. So here x is 1, so 4 into 3, so I get 4 into minus 2, that is minus 8, less than 0. So if RT minus S square is greater than 0 and R is less than 0, then this point 1, comma 0 is a point of relative maximum, right? Relative maximum. And I think by the previous argument you are very much smart enough to understand that if I take minus 1, comma 0 also, the same thing will happen, because here in place of x you will put minus 1, so the x square will become 1, so you will get the same value, and R will also have the same value, because if you put minus 1, then also 4 into 1 minus 3x square will remain minus 8. So both the points, that is 1, comma 0 and minus 1, comma 0 are the point of relative maximum. So I write plus minus 1, comma 0 are the point of relative maximum. So we already have talked about this 1, comma 0 and minus 1, comma 0. So till now I already have talked about 5 points. Now let us talk about these points 1, comma 1. So at 1, comma 1, I hope you are not getting confused. If I talk about RT minus S square, it will be minus 16 into 1 minus 3 into 1 minus 3. So minus 16 into minus 2, right, and into again minus 2. So how much is that? It is minus 64 less than 0. So if rt minus s square is less than 0, we don't have to investigate further. We can say that 1 comma 1 is a saddle point. It is a saddle point. Now the important thing is, and as you are mature enough to understand, that if I take 1 comma 1 or minus 1 comma 1 or 1 comma minus 1 or minus 1 comma minus 1, the function, the rt minus s square value will remain same, because its value is 1 minus 3x square. So x is 1 or minus 1, 1 minus 3x square will remain same. Y is 1 or minus 1, it will remain same. So all these, for all these points, the rt minus s square value will remain minus 64. And so not only this 1 comma 1, but rather all these points 1 comma, I can write it all together, plus minus 1 comma plus minus 1. All these 4 points are saddle points, So in this problem, actually we have got 5 saddle points: 0 comma 0, 1 comma 1, 1 comma minus 1, minus 1 comma 1, and minus 1 comma minus 1. And then we have got 2 points which are the points of relative minimum, right, like 0 and plus minus 1, and 2 points plus minus 1 and 0 are the point of relative maximum. I hope you have understood. In case if you have doubt, solve it yourself and let me know in the comment section. Okay, now this is another interesting problem. We already have completed 3 problems, and but I want to solve 5 problems as I promised. So let us quickly solve this one, and then in the end I will solve this problem, and I will also give you some homework kind of exercise. So keep watching till the very end. So solution: examine the given function for extreme values. Okay, so the function is f of xy is this. Okay, so what is the first step? Find f of x, partial derivative. So x4 will give me 4x cube, this 0, so it will give me minus 8x, and 4xy, so it will give me plus 4y, and that we have to put is equal to 0. So if I just simplify it for our convenience, I can take 4 common. So I will get what? I will get x cube. I think we made a mistake here. X to the power 4, 4x cube, and it will be 4x only. Sorry. You know, this is what happens when you just lose the concentration. So minus 4x plus 4y. So I can take 4 common. So I will get x cube minus x plus y is equal to 0. This is our first equation. Now I find f of y. So what is f of y? Y4 will give me 4y cube. Now 4xy, right? So 4xy will give me plus 4x, and then I will get minus 4y is equal to 0. So I will get y cube plus x minus y is equal to 0. I hope there is no confusion here. I have differentiated this, so 4x cube, and this will give me minus 4x, and this will give me 4y. And if I differentiate it with respect to y, 4y cube and 4x and minus 4y. So I have got these two equations. I have to solve them together, these two simultaneous equations. In the previous two problems, I was getting equation in terms of x and y, so I was directly getting the values, but here we are getting simultaneous kind of equation. So how to solve it? So I will suggest you to pause the video and try doing it yourself, but here I am continuing. So what we can do, we look at the equation 1 and 2, and if you look at the 1 and 2 equation, you notice one thing, that if you add them, minus x and x will cancel and y and minus y will cancel. So if I add, let me write it, adding equation 1 and 2. So if I add equation 1 and 2, I will get what? X cube plus y cube is equal to 0. And from this we can write that y is equal to minus x. Okay, so y cube is equal to minus x cube means y is equal to minus x. Now what I am going to do next is that I am going to substitute this y is equal to minus x in equation 1. So I write that from equation 1, I write x cube minus x, and in place of y again I write minus x using this. So that is equal to 0. So now we have equation in x, so I can write x cube minus 2x is equal to 0. So from this I can take x common and I will get x square minus 2 is equal to 0. So therefore we have got x is equal to 0, x is equal to under root 2 and minus under root 2. So if x is this and y is equal to minus x, so y will be equal to 0. For 2 it will be minus under root 2, and for minus under root 2 it will be under root 2. So we have got three critical points. We have got the points for 0 we are getting 0 comma 0. For x is equal to root 2 I am getting under root 2 comma minus under root 2, and for x is equal to minus under root 2 I am getting minus under root 2 comma under root 2. So first step is over. I got three critical points. Sorry, I'm suffering from sore throat, but since I have to create video, I have to continue. Okay. So what is the next thing? Next thing is that we have to calculate r. So if I calculate r here, r is f of xx. So if I differentiate this f of x again, so I will get what we have 4x cube, so it will become 12x square minus 4. So I can take 4, let me leave it as such, 12x square minus 4. And if I have to calculate s, let me write it over here so that I can save a space. So I have to differentiate fy with respect to x. So this will give me 0. Here I will get s is equal to 4. And what is t? So t, if I have to differentiate this with respect to y, so 4y cube will give me 12y square minus 4. So r, s and t we calculated. I'm moving to the next page. So next is I have to calculate rt minus s square. So rt minus s square is how much? It is 12x square minus 4 into 12y square minus 4. So let me write it, 12x square minus 4 into 12y square minus 4. And s I have got how much? 4. So I write minus 4 square, that is equal to minus 16. Now what is the next thing? I have to evaluate the nature of the function. So first I take the point at point what are the first point? First I take the point 2 comma minus root 2. I will take 0 0 later because that will be a special case. So I am going to talk about this first point, under root 2 comma minus under root 2. You could have taken 0 0 also, but just to highlight that here I will come across a situation at which rt minus s square will become 0. So that is why I am going to consider it in the end. So at root 2 comma minus root 2, what is rt minus s square, ladies and gentlemen? So 12 into 2, so 12 into 2 will be 24, and 24 minus 4 will be 20, right, into, if I put y is equal to minus under root 2, so yeah, again 12 into 2, 24 minus 4 is 20, and minus 16. I am not going to evaluate, but one thing I am certain that this is greater than 0. Positive you can write after evaluating it. So if rt minus s square is greater than 0, then we have to evaluate r. So what is r? R is 12x square minus 4. Yeah. So 12x square. So x is under root 2. So 12 into 2 and minus 4. So 24 minus 4, that is equal to 20. So it is greater than 0. So rt minus s square is also greater than 0 and r is also greater than 0. So this is a point of a relative minimum. Relative minimum or local minimum because some of you may think that I am using the term relative only, not local. Okay, now the next thing we are going to calculate at minus under root 2 comma under root 2. So this point will give me like rt minus s square. Again 20 into 20, 20, 20 minus 16. Again, this is greater than 0, right? And uh, then if it is greater than 0, I have to calculate r. So r is also 12, and it will be like 2 minus 4, that is equal to 20. This is also greater than 0. So this is also a point of local minimum. Both are the point of local minimum in this case. Okay. So now as I told you that I'm going to look at the point 0, 0 comma in the end. So now I'm going to calculate the rt minus s square at point 0 comma 0. So at point 0 comma 0, rt minus s square is what? It will be like 12 into 0. So 12 into 0, 0 minus 4. So I will get minus 4 from the first bracket. Y if I put 0, again I will get minus 4. And then I write minus 16. So 16 minus 16 is equal to 0. So I have come across this situation for the first time. We already have come across the other situation where rt minus s square was greater than 0, less than 0. But this situation I came across for the first time. Means further investigation is needed. What is the further investigation? So look at this very carefully. For our convenience, what we are going to do, we are going to write the function one more time. So the function is x to the power 4 plus y to the power 4. So let me write the function here, sorry. So the given function is f of x comma y is x to the power 4 plus y to the power 4, and minus 2x square plus 4xy. So minus 2x square plus 4xy, and then minus 2y square. So this is what we have got, right? So if you calculate the function value at point 0 comma 0, what will happen? Everything will become 0, so you will get the function value at point 0 comma 0 at 0, right? Now what is the meaning of the further investigation? Because this method is failing. So now I am going to look at this thing here and be careful, because this is not something that you have to do in all the problems. For different problem there may be a different situation and you have to use it very smartly. So I'm talking about xy plane, and I have calculated the function value at 0 comma 0, and what I have got is equal to 0. Now what I do, I move along the x-axis. Suppose I say this is x-axis and this is y-axis. So in the neighborhood of this point, suppose I take a point in the neighborhood of the point 0 comma 0, right? So in the neighborhood of the point, when I am moving along x-axis, let me write for points, let me write like this: for points along x-axis, one thing is clear, that if you move along x-axis, y is equal to 0. So along x-axis, if you calculate the function value f of x comma y, the y will be equal to 0. So you will get something like x to the power 4 minus 2x square, and this is nothing but x square common into x square minus 2. Now if you take a point very close to 0, for example, if you take x is equal to 0.1, right? So if you take x is equal to 0.1, this value will be negative, right? Means for points along x-axis, if you take a point in the neighborhood of origin, means if suppose you take a point like 0 comma 0.1 comma 0, x is 0.1 and y is 0. So at this point the function value will be what? The function value will be less than 0. It will be negative. Okay, I can write it. So function value in neighborhood, which I write NBD, as it is a standard term, neighborhood of origin along x-axis is negative. So it means what? That at 0 0 it was 0, but if you move in the neighborhood, the function value is negative, means the function value is decreasing, right? I'm going to make another argument, but since I don't want to move to the next page, I'm trying to incorporate here. So now I am going to move along the line y is equal to x. So this is the line y is equal to x, and along y is equal to x, I am writing here, and you can manage. So along y is equal to x, what will happen? The function will become what? The function will become f of xy will become, if you put y is equal to x, x to the power 4, y is equal to x, so again x to the power 4, and so they will get 2x to the power 4, and it will become 4x square and minus 2x square and minus 2x square, so it will become 0 if you put y is equal to x. So if you move along this line, that is y is equal to x, so the function value is 2x to the power 4, and 2x to the power 4 is always greater than 0. So if you move along this side, the function value is becoming positive. At 0 0 the function value was 0. If you move along this side, along x-axis in the neighborhood, the function value is negative. But if you move along the line y is equal to x, the function value is positive. So means the point 0 comma 0, in one side it is what? It is decreasing, on the other side it is increasing. So the 0 comma 0 is a saddle point, because saddle point is a point in which it is neither a maximum nor a minimum. So I can conclude that 0 comma 0 is a saddle point. Saddle point. I hope I have been able to explain it properly. I repeat it before I move to the next question. What I am trying to explain here, that I have calculated the function value at 0 comma 0, and then I moved in two different directions, one along x-axis. Then I calculated the function value at a specific point, for example 0.1 comma 0, and I am getting the negative value. But if I move along the line y is equal to x, no matter what I take the value, any small value also, because the function value along y is equal to x will become 2x to the power 4, so this will always be positive. So in one side it is decreasing, on the other side it is becoming increasing, means more than 0. So that is why this point is a saddle point. Okay, fine. So let us quickly answer this question before I wind up this video. And in this question I am just asking you to calculate the critical point. So I think we already have kind of done many problems. So now I leave this video, this question for you to complete. So complete the question, find all critical points. This is a question which may be asked in the exam, important question, and let me know in the comment section that what are the critical point for this function, right? So this is the question number 1. Take the screenshot, and I have some more question for you for homework. So there are 3 more questions. Pause the video, take the screenshot, and let me know that what are the answers for it. So this is all about this here. We talked about maxima minima of function of 2 variables. In the next video I will talk about the Lagrange's multiplier method, and as far as the absolute maxima or minima is concerned, in case if you wish I can create a video, but just let me know through the comment section. So that is all from my side in this video. Thanks for watching and have a great day.